In my last video, I explained capacitors. Capacitors can be connected in two ways, series and parallel. First, let us see capacitors connected in series. Here, three capacitors C1, C2, C3 are connected in series to a potential difference V. From the negative terminal of the battery, electrons will flow to the right plate of this capacitor C3 minus Q. Will flow. Electron of charge minus Q will flow to the right plate. So it will push equal amount of electrons to the right plate of capacitor C2. So it will become negatively charged. Then same way, this will push same negative charge to this plate. So this will become positive and this will become negative. And the left plate of this capacitor will push electrons to the positive terminal of the battery. So this will become positively charged. So each capacitor, there will be a charge of Q. Same charge Q and Q, Q. But the potential difference will be V1, V2, V3. Then capacitors are different usually, C1, C2, C3. Then total voltage V can be written as V1 plus V2 plus V3. Then Q is equal to CV. So V can be written as Q by C. So here voltage is V1. So V1 can be written as Q by C1. Similarly, V2 is Q by C2. V3 is Q by C3. So V is equal to, instead of V1, we can write Q by C1. V2 we can write Q by C2. V3 you can write Q by C3. Then this three capacitors can be considered to be a single capacitor of equivalent capacitance CS. So charge stored on this is Q. So V can be written as Q by CS, where CS is the effective value of the capacitance when it is connected in series. So now this Q will get cancelled. So we will get this expression 1 by CS is equal to 1 by C1 plus 1 by C2 plus 1 by C3. So this is the expression when capacitors are connected in series. CS is the effective value of the capacitance. So the reciprocal of the effective value of the capacitance is equal to sum of the reciprocal of the individual capacitances. Capacitors in parallel. Now, three capacitors C1, C2, C3 are connected in parallel across a potential difference of V volt. Now, potential difference across each capacitor will be same. It will be equal to V. But the charges will be different. Charge on the capacitor C1 is Q1. Charge on capacitor C2 is Q2. Charge on capacitor C3 is Q3. So total charge we can write like Q is equal to Q1 plus Q2 plus Q3. Then Q is equal to CV. So charge on the first capacitor Q1 can be written as C1V. Charge on the second capacitor can be written as Q2 is equal to C2V. Charge on the third capacitor Q3 is C3V. So you can substitute for Q1, Q2, Q3. Now, this three capacitors can be replaced by a single capacitor of effective value CP. When it is connected in parallel, effective capacitance is CP. So for this Q, we can write Cp into V. So now this V can be taken outside. So this V will get cancelled. So effective value of the capacitance when it is connected in parallel is equal to C1 plus C2 plus C3. So effective value is equal to sum of the individual capacitances.